In this video, we want to look a little bit more at antiderivatives and why they're so important. So with antiderivatives, capital F of x and capital G of x, they're both antiderivatives of a single function f of x on an interval. Then there's a constant c such that capital F of x minus g of x is equal to c. Now what this basically means is that two antiderivatives of a function differ by only a constant. Now that arbitrary real number c is called an integration constant. Okay, now this brings us to the real crux of the matter, where we have if capital F prime of x is equal to little f of x, in other words, capital F, its derivative is little f, then the integral of f of x dx is equal to capital F of x plus c. Now, for any real number c. So this is read as the integral of f of x dx is equal to capital F of x plus c. This symbol right here is the integral symbol. Little f of x is called the integrand, and dx is the integration variable. Capital C is the constant of integration. Now, taking this entire thing together, the integral of f of x dx is called an indefinite integral. Awesome. Now, here's the thing. When people start doing integrals, and it's an indefinite integral, it doesn't have limits of integration here, then this c needs to be here when we're done, because you can write down the original antiderivative that you would normally think of, but you can have any other constant on there as well. So you have to have that plus c there. Now, there is a power rule. So this is really going to help us quite a bit here. For any real number where n is not equal to -1, the integral of x to the n dx is equal to x to the n plus 1 all over n plus 1 plus c. Now, remember with derivative, so d by dx of x to the nth power is equal to n times x to the n minus 1, right? Well, the antiderivative, or the integral, is the opposite of taking the derivative. So instead of adding 1 to the instead of subtracting 1 from the exponent, we need to add 1 to the exponent. And notice with the power rule, we bring the n down in front and multiply. Instead, we're going to divide by whatever is up here when we have the n plus 1. And of course, down here, the antiderivative of f of x equals x to the n for n not equal to 1 is found by increasing the exponent n by 1 and dividing x raised to the new power by the value of that new exponent. Alrighty. So I'm going to go ahead and see you in the next video where we're going to practice this. Have fun.